All right, today we're diving into a technology that feels like it's pulled straight from science fiction. We're exploring the very edge of reality, a field that is set to redefine everything we think we know about computers. Welcome to the world of quantum computing. And I want to be clear, we're not just talking about a faster laptop or a more powerful phone. No, this is a complete revolution. It's a fundamental shift in how we process information, one that could solve problems we currently consider impossible and, yeah, turn science fiction into actual scientific fact. So where do we even begin? Well, we have to start by understanding that this is a completely new frontier for computing. We're pushing way beyond the rules of the classical computers we all use today and into the strange, almost magical world of quantum mechanics. And at the absolute heart of this new frontier is a brand new kind of building block. So let's talk about the magic of qubits, because this is where these machines get their incredible, mind-bending power. Okay, this slide really gets to the core of it. Your computer, your phone, everything right now is built on bits. And a bit is simple, right? It's like a light switch. It's either on or it's off, a 1 or a 0. But a quantum qubit, that's more like a dimmer dial. It can be fully on, fully off, or, and this is the crazy part, it can be both at the exact same time, and every single value in between. This wild ability to be in multiple states at once has a name. It's called superposition, and this is where the real magic starts to happen. See, if you have two classical bits, you can represent just one of four possible combinations at a time. But with two qubits, thanks to superposition, they can hold all four combinations simultaneously. And this power just explodes as you add more qubits. We're talking about a massive number of calculations happening all at the same time. And if that wasn't weird enough, then you have entanglement. Einstein famously called this spooky action at a distance. Imagine you have two coins that are mystically linked together. If you flip one and it lands on heads, you instantly know the other one is tails, even if it's on the other side of the planet. Entangled qubits work in a similar way. They have this deep connection that allows for incredibly powerful and coordinated calculations that are just, well, they're completely impossible for a regular computer. So you're probably wondering, okay, weird physics, but what does this actually do for us in the real world? Well, it means we are right on the verge of solving the unsolvable. And let's be really clear about what we mean by complex problems. We're not just talking about things that are a little difficult. We're talking about calculations that would take the fastest supercomputer on Earth today longer than the entire age of the universe to finish. I mean, problems that are, for all practical purposes, impossible. The impact this could have is just staggering. Think about medicine. What if we could design new life-saving drugs by perfectly simulating how molecules behave? Or in cryptography, creating truly unbreakable codes, while also being able to break our current ones. Quantum computers could optimize global shipping routes in real time, or supercharge AI by finding hidden patterns in data that are far too complex for any machine we have today. The possibilities are huge. Okay, so if this technology is so powerful, what's the holdup? Why isn't it everywhere? Well, that brings us to the quantum hurdle. It really is the key question, isn't it? And the answer is a fascinating paradox. The very same quantum weirdness that gives these qubits all their power also makes them incredibly fragile and ridiculously hard to control. The biggest enemy here has a name. It's quantum decoherence. The best way to think about it is like trying to listen to a whisper during a hurricane. The tiniest little disturbance, a small change in temperature, a stray vibration, anything, can cause the qubit to lose its quantum magic and just collapse into a normal 1 or 0. And poof, your entire calculation is ruined. That's why building these things requires creating some of the coldest, quietest, most isolated environments on the planet. But here's the thing. Despite all those massive challenges, this revolution is happening right now. Which leads to the next question. What about your quantum future? How can you actually be a part of this? You know, the path to joining this frontier is probably more accessible than you think. It starts with things like coding and math, and it's definitely rooted in physics. But honestly, the most important thing you need is a totally new way of thinking, learning to be comfortable with probabilities and possibilities instead of just simple yes or no answers. And that's because, at its core, quantum computing is so much more than just a new tool. It's a new perspective. It teaches us to embrace complexity, to understand that the world isn't always black and white, and that sometimes the best solutions come from looking at all the possibilities at the same time. This whole journey is really just beginning. And yeah, the path forward is going to be challenging, for sure. But the potential rewards for science, for medicine, for all of us are just immense. We are truly standing at the dawn of a completely new age of computation. So I'll leave you with a final thought to chew on. As we start to build these incredible machines that can see and process countless possibilities all at once, what critical possibilities might we be missing in our own lives?